still some more people dropping in, but let's start already so we will have enough time for today's conversation. So good afternoon, everyone, and welcome to this Smart Otaniemi webinar on sustainable batteries. Great that you have decided to join us today. My name is Tytti Nikunen. I'm a communication specialist at Smart Otaniemi, and I will just go through some practicalities before we start the actual panel discussion. So first of all, we are going to record this webinar, and it will be available on our YouTube channel soon after. So if you want to get back to the theme, just go there and you can see everything again. And please remember to keep your microphone muted during the webinar. And in case you have any questions, please don't hesitate to write them in the chat box. So if you want to address your questions to a specific speaker, just add their name in front of your comment. Next, you will see today's agenda. So I will start with a short introduction on Smart Otaniemi, our innovation ecosystem, and then we will get to the actual business very soon. So just a couple of words about Smart Otaniemi to start with. As many of you might know, Smart Otaniemi is an innovation ecosystem that connects different kinds of organizations and professionals to work together on world-changing solutions. And smart energy solutions are at our core, but our ecosystem environment encourages the network to develop holistic and cross-sectoral solutions. So that's all that I'm going to tell you about Smart Otaniemi today. If you want to know more, just please visit our website. The address is smartotaniemi.fi, or you can also write us email, smartotaniemi@vtt.fi. I will write these addresses to the chat so you can find them from there easily as well. But now let's get to the point already. I will shut down and leave the floor for our brilliant experts. So please, Maria, feel free to start the introduction on today's theme.
Okay, thank you, Tytti, and welcome to this panel discussion today. My name is Maria Wilkman and I come from VTT. I work here as a senior scientist, and my background is in printed and flexible electronics and solar cells and so on. But for the past few years, I have been working more and more with batteries, since I think this topic is a really fascinating one and really important as well. I will give you today just a very short and very simple introduction to the topic of today, and then we will continue with the panel discussion. So yes, thanks. So about the battery demand, how much batteries we will need in the future? Well, quite a lot. It has been estimated that in 20 years we would need 50 times more batteries than currently. And it is also estimated that we need to increase the energy storage exponentially during the next few years. So we need to make a lot of more batteries than at the moment. We need those in portable devices, in electric vehicles, and also as stationary energy storage systems together with solar and wind parks and so on. So there are many kind of applications where we need batteries. And next slide, please. Yes, and as you know, most of you know, the most common battery we use today is the lithium-ion battery, very well-known chemistry for many of us. And here is just a simple image of the battery, which consists of the cathode and anode. The cathode is a lithium metal oxide, anode usually a graphite-based material, then the lithium ions travel through the separator between these two parts. And then as the current collectors, we use copper and aluminium. And next slide, please. So what materials we then have in the lithium-ion batteries? I have listed here the most common materials, so cobalt, lithium, nickel, copper, aluminium, and manganese. And on the left-hand side, you can see the periodic table, which shows how much actually we have all the elements on Earth. And the materials that are marked with yellow, they have limited availability and future risk to supply. And the materials with orange color have a rising threat from increased use. And I have now circled these battery materials on this table of elements, and you can see that most of them are marked as limited availability or having rising threat. Aluminium is the only one which is shown as green. So this is a topic I would like to discuss today with our experts, since this doesn't look so good to me, and I would like to kind of understand better that do we really have a problem with the materials, and how much materials we need for making all the batteries that we are planning to prepare in the near future. And if this is a problem, how big of a problem is it? So that was the short introduction today, and then I would like to continue with the panel discussion with our great experts today. So let's first introduce ourselves shortly. We have today 4 panelists, and I can see Tanya on my screen as the first one. So Tanya from Aalto University, can you please introduce yourself shortly?
So good afternoon, everybody. I'm Professor Tanya Kallio from Aalto University School of Chemical Engineering, and my field is electrochemistry. I've been working with the lithium-ion batteries now for some 10 years. Our focus is on the material development and understanding the interfaces in batteries.
Okay, thank you, Tanya. Next on my screen is Andras Kovac.
Hi, I'm Andras Kovac, CTO at Broadbit Batteries. Broadbit Batteries is a battery startup company. We work on sodium salt batteries and also on innovative lithium-ion electrolytes.
Okay, thank you, Andras. Then we have Simon Michaud from GTK.
Yes, hello. I'm from GTK. I'm a professor of geometallurgy. I was trained in the Australian mining industry. I came to Finland to work in the mineral intelligence sector, where my primary goal was to work out how much mineral resources were needed to feed the gigafactories of Europe.
Thanks. And then we have Ilkka Homanen from Business Finland.
Hello, this is Ilkka Homanen, Business Finland. I'm representing so-called Batteries from Finland initiative, which means that Business Finland is promoting battery ecosystem from Finland towards Europe and other markets, and we are supporting ecosystem development around different verticals. And I'm happy to see that there's a lot of material experts here. I'm not a material expert, but for this panel, I'm trying to bring in, let's say, more of a overview, holistic view, what things are and how the development looks like from our perspective. Thank you.
Great, thank you all. Very nice to have you here today. So let's start with the big question. So will we have enough materials to produce all the lithium-ion batteries we are planning to produce? Simon, what do you think? You have made a recent survey about this.
Yes, the answer to that question is we don't have enough minerals for lithium-ion batteries per se in their current form, but there's plenty of materials around if we look at all other chemistries, right? And so we've got to be open to the idea of different kinds of batteries for different kinds of applications. Now, the basis of that, I did a recent study where I looked at if we were to replace our existing system of cars in a global context with electric vehicles, and there's 1.4 billion vehicles in the global fleet. If we did that, how many batteries would we need? How large would they be? And then that would then translate to how much lithium, cobalt, and nickel will we need for those batteries. And this is a global challenge. We either arrive there together or not at all, because most of these minerals are supplied outside Europe. We don't control the supplies of those minerals. So we are in competition through the market with groups like China and the United States. So my approach was to look at the global system and then look at how big the European system would be and the United States system and the Chinese system. But I did it on the conventional lithium-ion battery solution, which is what the people in Brussels would like to see as the only solution in front of us. But actually that's not true. There's lots of options that we could look at that are amazing, that are actually outside lithium-ion. And in fact, I'm a fan of Broadbit. I liked what Broadbit was actually sort of doing, and I would like to hear what Andreas was actually thinks about all this.
Yes, thank you, Simon. Really interesting to hear your views on this topic. What about Ilkka? You have been involved in many European kind of initiatives. So what do you think?
Yeah, it's a complex issue, I must say, and let's say having enough materials or not, it varies. All in all, I think battery business and the electrification, it's all the forecasts are good news after each other. I haven't seen any forecast going downwards until now, so they are all going upwards, which means that I think it's a matter of, on the other hand, it's a matter of how to manage the exponential growth throughout the value chain, and it might also hit to the materials side. As I said, I'm not an expert on the materials, but I have also seen how the battery chemistry roadmaps look like, and for me it shows that there's a lot of different sort of routes to be taken, which have an impact to the needed materials and the chemistries. But I think it's on the other hand, you can say that we don't have enough materials, but it depends to a large extent to multiple factors. I think all these estimate models are also based on a certain, let's say, penetration growth on the global markets. Will that happen or will that not happen? One of the latest, let's say, electric car penetration estimates I have seen, what that shows is that currently European EV car sales is peaking upwards, and on the other hand, if you look at the US and China, they are like saturating or even coming down, and that's due to some let's say changes on the incentives, and also due to let's say fast growth situation in Europe. So my message is that the model which estimates all these let's say resources, if they are not, or if there's enough or if there's too little, it's very complex and it depends on multiple factors. So for me, it's impossible to say whether yes or no.
Yeah, that's true. Okay, thank you. So before we go to the new and exciting materials, I would still like to ask from Tanya that what do you think, what are the most critical materials with the current battery chemistries regarding the availability?
Well, the cobalt, which is used for the lithium-ion battery positive electrode materials, is been already some time recognized as the most critical material for lithium-ion batteries. And the reason for that is that it's mostly produced in Congo. So there's what concerns related to the for its availability due to geopolitical reasons. More than 50% of cobalt mine production is actually in Congo. Then the refined cobalt production is in China, almost producing 50% of the refined cobalt production. But the good news to us Finnish persons is that Finland is actually the second largest cobalt refined producer. So we have some 30% share of those productions. And based on kind of the mid estimations or forecast, the demand for cobalt increases by a factor of 2 from the current level in the next 10 years. And the second critical material is considered as the negative electrode material, graphite. Its forecasted increase for demand is much more modest. It's only factor by 0.5 in the next 10 years. And there are also alternatives. So mainly the graphite comes now from China, but in case the graphite price, natural graphite price increases too much, we can replace it with the artificial graphite, which is today more expensive. Then actually very recently also lithium has been added in the list of critical raw materials by EU. And there's actually no concerns in the near future lithium production, but in the midterm, there might be difficulties for meeting the lithium demand. So it has been forecasted that the lithium demand increases by a factor of 6 in the next 10 years. And most of lithium comes from South America. And there's also some production also in Australia. And as for the nickel, it's we actually have enough nickel to cover the forecasted need. But there the issue is that when we are having more and more nickel used in making the positive electrode materials, we don't have enough high purity nickel. So the refining capacity is not high enough, even though the known nickel deposits are high enough to meet our expected need. So I would say that these are the most critical materials for the current lithium-ion battery technology.
Okay, thank you. What about Andras as a battery producer? What are your views on this topic? Which are the most critical materials?
Well, I agree with Tanya about the list of materials, and our mission as a battery startup company is to provide a plan B for what can be done to alleviate these bottlenecks. And there can be evolutionary or revolutionary approaches. So the easiest evolutionary approach is to use lithium iron phosphate cathode. In that case, there is no need for neither nickel or cobalt. And lithium iron phosphate has been actually the originally developed battery cathode. So recently the Nobel Prize was in chemistry awarded for its development. And today it's regaining its popularity mainly because of the reasons that Tanya mentioned. There is renewed interest for that. However, there is a trade-off because it has significantly lower energy density than NMC cathodes. So then an intermediate step is to use lithium iron manganese phosphate, which is a version of the lithium iron phosphate that has same discharge voltage like NMC, and again no nickel or cobalt there. And after these evolutionary approaches, we think that the actual big step forward is to use sodium salt battery, which we are working on. In that case, all of the ingredients can be locally sourced, so they're not only widely available, but also there is no uneven geographic distribution. So we are working on development of sodium salt battery, where sodium fluoride, sodium chloride salts are the main ingredients, And for the electrolyte also, we have simple inorganic chemicals such as sulfur dioxide, which can be easily produced.
Thank you, Andres. So you are betting on the sodium-based materials for the hopefully near future solutions to replace the lithium-based batteries.
And they'll do quite well.
Yeah. Great. Thank you. Tanya, would you like to still comment on the new materials for the batteries? Do you think what kind of other options we have in addition to the materials Andras mentioned?
So there are a lot of development going on also in positive electrode materials for the lithium-ion batteries. So to replace these nickel-rich materials, but unfortunately at the moment there are issues related either those material durability or then the energy density. So if you are then thinking about the electric vehicle application, these are the two important properties for the materials. And of course, we need to also think what applications we are targeting at. So for the electric vehicles, this energy density and durability are important. And then also there are developments on the electrolyte materials, which could then affect actually quite greatly also the durability, which you can get from the batteries in combination with different electrodes. But if we think then some other applications where we don't have so high energy density demands, we could go actually completely different kind of materials, for example, like bio-based materials, which could be then used batteries which are needed for example, portable electronics where you don't expect to have so high lifetime or cycle life from the batteries, or where you don't expect to have so high energy density.
Yeah, then we would kind of save the lithium materials for those applications where we need them the most as well.
Yes, that approach is excellent.
Yeah, thank you. What about then if we now all agree that we should also focus on the novel materials as well? So I understand that the money is kind of going to the lithium-ion batteries at the moment, and it's kind of a bit difficult to find funding and investment for these novel materials, since there are always, of course, risks involved when you take new chemistries into use. So how do you see how we could secure enough funding and investments for these new chemistries? Do you, Ilkka, have some views on this topic?
Yeah, thanks for the question. I will take a kind of another type of view on this one, pointing out that currently, as many of you know, there's a huge amount of investments made in Europe for lithium-ion based capacities. So that's going to take a whole bunch of money involved into those capacities, and also that might impact also to interest to invest to novel material development. But on the other hand, I must say always that there's plenty of money in the world to be utilized for some new things also. So if the idea is good and viable, there's money available also. And that also, let's say, covers this topic here. But I think it's worth noting that lithium-ion investments are so huge that that's going to kind of dominate the situation, at least in Europe currently.
Yeah. What about Simon?
So I have to me, the current battery market is operating the way it does now because we're still in the uptake phase. Like I think the fleet of electric vehicles worldwide was around 5.2 million last year. It's something like that. Right. Well, if we have 1.4 billion vehicles in the global fleet, we've got less than 1% are now electric. Like it's up like 0.38%. So we have many more vehicles to make in front of us. So the market at large still does not see the electric vehicle as a primary reason to be. Right? We're still thinking in the fossil fuels mentality for the majority of cars being produced, and the cars being run. Now the problem with that is oil and gas. I did a report on this a few years ago. Is about to become unreliable as a source, and it's not that they're running out of oil; they're running out of money. Just prior to COVID, 9 out of 10 oil producers in the US tight oil sector had a cash negative profile. Now then COVID's happened and the price has dropped. Most of those companies are out of business, right? So for them to come back, it requires a brutal price correction for the price of oil to go up. So if that stays the same, then everyone has to transition across to an electric vehicle, which means the demand for electric vehicles will be much more different, and people will take it more seriously, and we'll see a lot of that extra money that's used for other things start flowing into this sector, and we'll see start seeing some of the scale-up issues and problems that we have yet to encounter. At the moment, it's like I call it like the calm before the storm. And it's not like an opinion or a nice thing to do that we have to do this. We absolutely have to do this, and it's upon us in the next few years, right? And so what I'm saying is the mechanics of that market, when we see it a few years from now, will be very different to what they are now. And ride the wave.
Yeah, thank you. That sounds kind of encouraging.
Yeah, I could add a little bit to what I said and what Sam was saying. Let's say after providing a kind of a strong statement on lithium-ion capacities in Europe, of course there are interesting times to be seen when considering let's say characteristics needed for the batteries, sustainability issues, and also when Simon was saying that when we are scaling up the high volumes. Because it's a cost performance game in the end, because it's so high volume what we are seeing here to be developed. So all these issues are kind of impacting to the final let's say investments made for the current technologies, for the future technologies. So again, there's a lot of different aspects to be considered in the future.
So for those who are interested, I just put in the chat box a link to a report of mine that was released in 2019 on the outlook for the oil industry. And that right there is the best advertisement in the world for why electric vehicle batteries should be considered.
Thank you. And you have also had a nice talk, which you have a recording on YouTube.
Oh, yes, of course.
You can also advertise that as well.
I'll find that and put it in the chat.
Great, thank you. Okay, yeah, so if we will take the new materials into use, either in electric vehicles or as stationary storage devices or in portable devices, so will they be good enough? Are they good enough for those applications? And what actually good enough means? Does it mean high energy density, or would something else be sufficient? Would you, Tanja, like to comment on this?
Well, let's say that the electric vehicle is, I think, one of the most demanding applications, because there we have a reference point. We have our internal combustion engine cars, so we would expect to have something similar. So even the current lithium-ion batteries don't exactly meet those expectations which we have based on the old technology. So based on the charging time, for example, or driving distances. So we would still like to actually improve even the existing lithium-ion batteries, going towards these next generation batteries. But if we look some other applications like stationary applications, for those ones, we don't need actually materials which offer such a high energy density, because we can store them energy in a larger volume. So there is actually good chances for some of the new materials to be used and new chemistries, just like a sodium battery, to be used, where the energy density is not just high. And as I already a little bit referred earlier, so we have also investigations going on bio-based battery materials. And this could be something which could be, again, used in a very different type of application, where we have less strict demands for the energy and power density of the batteries.
Yeah,
yeah, really should have a look on what is the application, what we have, so that we don't put the lithium-ion battery and the critical material in and increase the material criticality issues in that way.
Yeah, what about Andres? How do you see the future for the novel materials? Are they good enough?
Yes, well I agree with Tanya that the electric vehicle applications are the most demanding ones, so the bar is set very high. At the same time, this is the big growth market. So our investors, of course, anticipate that we make batteries which are good enough either for electric vehicles or grid storage, ideally for both. So we have to meet these targets. There is a kind of runway. So one can start with niche applications. If a new material is good in certain parameter, you can start in a more niche application and then have some runway to develop the other parameters. So, for example, right now, the batteries which we are developing, they are better in the operating temperature range, in wide operating temperature range than lithium-ion batteries. It is currently a bottleneck because lithium-ion batteries degrade fast at elevated temperature. So let's say that we target these applications that need wide operating temperature range, and then we have time to improve all the other parameters to be the same as current lithium-ion batteries or better. So I would say that new material has to find first their niche and then have some runway to compete in all the other parameters with lithium-ion. And that's a difficult competition because the current lithium-ion batteries have 20, 30 years of engineering behind them and optimization. So that's why it's hard to meet all the criteria at the same time. So one has to with a focused direction.
What do you think? Is it enough to kind of, if you have a green or sustainable battery, is it kind of important enough, or should it be also low cost or high performance? Or
yeah, well, sustainability is more and more anticipated and expected for all the reasons that were mentioned before. But by itself, it's not enough. So that sustainability has to come together with the similar performance that we receive today from lithium-ion batteries.
Yeah. Okay. Then I was thinking, since it's kind of a huge task to build a manufacturing process and have the materials for new battery chemistries. So in addition to the material like sufficiency, there are many other things that we should solve before we can make a commercial battery. So what are the other bottlenecks we would need to focus in order to make this happen? Would you, Simon, want to comment on this?
So how do we go about this? Look, a lot of these things are, it struck me coming from Australia, from the mining industry in Australia when I arrived in Europe, and it struck me such a lot of money was being put around to talk about things. And we've been talking endlessly since 2008, where the innovative part is we actually go and do it. Guys like Ilka here has known what to do for some time now, but we've got to give him the money to do it. Right, so our society collectively at large has to understand what's in front of us. And then we have to make a decision and act like it's true. And we have to apply the information we already have. So it's not about finding a new way to do it. We know what to do, right? But we've got to change our own behavior in context of how we do things. And humans, as a result, don't deal with change very well. I would suggest the first thing we need to look at is transferring not just the electrical car market, but also start producing things like trains and trams and buses, electric buses that move lots of people, and have the infrastructure around the movement of large amounts of people in cities, and the governments and city councils to own those infrastructure outright, right? And so they are the leaders of the market. And I also think that I give a lot of thought, for example, on how do we get Finland to develop a battery ecosystem that secures our long-term future, and how do we do that, and how do we make sure it stays in Finnish hands? And it occurs to me, instead of actually sort of taking on the task of building everything, is certain actors should go in and take out certain decisive parts of the network. Like at the moment, who owns the Freeport cobalt refinery? Who owns that? The Finnish government has actually organised a group called the Finnish Minerals Group, or the FMG Group. They've now own a large mine called Terrafame. As we grade into a thing where minerals become much more valuable, that'll become a node. And because the existence of that mine in Finnish hands means all industry around it will kickstart and go. And so if we think in those terms, where we take out a few small but decisive places, but instead of just talking about it, we've got to go and do it. And when I say we, who is Finnish corporations and Finnish government should get together and start forming a collaborative thing with a business model of how does Finland stay sovereign 30 years from now. Because we actually had a group of Chinese investors turn up to GDK a few years ago and ask what deposits can they buy, right? Mineral deposits in the ground, and of course, that wasn't the right question. We weren't in a position to answer any of that, but they asked, right? So what I'm also saying is the conventional ways of doing things and this complacency that's been around since 2008, when we first sort of saw this, hasn't really helped us. There are solutions on the ground, right? But they really need action in terms of capital investment needs to flow into these areas in ways that are actually helpful. So to me, that's the bottleneck.
Yeah, I agree that we are not running out of the solutions. We have plenty of them. We just would need to make them happen.
And those solutions don't have to be perfect, because we'll learn by doing. Once we sort of get out the gates and we start doing things, it will become apparent that some solutions won't work very well. Okay, fine. It'll become apparent why, and a new solution will take its place very quickly, and we just do it.
Yeah.
Ilka, I imagine that Business Finland has tried to get a number of initiatives going, but we need to. Yeah, like you'd have an opinion on this, which would be very interesting.
Okay, thanks, Simon. Well, I can share some thoughts here. Yeah, a little bit of a story for participants here. I've been dealing with the battery business for, say, almost 3 years now, and one of the first experience I had was going to the European Battery Alliance meeting to Brussels, because we knew that there's a lot of European, let's say, company networks available, there's financiers available, there's a lot of talks about the future. And it was precisely like this, that there was a Volkswagen director talking about their challenge on, let's say, fitting into European regulation of low carbon future, and they said that, guys, we are going to change the whole model set to electric, and please help us to do that. And then in the same meeting, there was a lot of discussions how to build in the capacities for cell manufacturing and all the things, let's say, the value chain along to support that development. And it was kind of surprise for me to figure out that financing was available, but they said that they couldn't finance the capacity building due to the risk profile of the investment. So I figured, I'm not an economist, but I could figure out that there's not a demand risk, at least on the battery business, to be seen. So that was one bottleneck. The financing was missing, and now currently it looks like there's a huge amount of cell capacity under construction or under planning in Europe, and the next phase of the bottleneck is like a thrown, let's say, backwards on the value chain to cover the chemical plants capacities and even to the materials and the mining. So we are kind of going step by step backwards, let's say, facing some capacity risks at least along the way. So I like to say that this is a explosive growth, and it's not going to be a smooth road. But of course we will make it, but not without bumps on the road.
So who owns all those new assets coming in, and how much of it's European?
Well, some of it is European, and some of it is like Asian, as we all know.
Yeah.
So it's a mixed situation, and that's the thing.
So I was part of a group that we had a briefing where every large car manufacturer in Germany has been advised to secure outright control of mineral supply in a mine, as in go out and buy a mine that supply all the minerals they need. All four major car producers in Germany were recommended to come together, form a consortium, and invest in a series of mines. They said go to Africa, and those raw materials going, because they foresaw a situation where the business environment that's coming in requires all entities to have a vertically integrated value chain, where everyone in that company or group of companies has some influence or control over everything they actually need. Now that's what the Chinese have done, but the Europeans have yet to come to terms with this, I think. And this is something that we are having. I don't know what the right word is. We still think it's like we're partying like it's 1985. We're living in the past, about 20 years.
By the way, I would like to add one more topic into the discussion. I think we haven't even touched that item.
Yes, sure.
Talk about whether we have enough materials or not, whether we comply with sustainability targets or not. We need to consider the recycling of the materials as well. So it's not the discussion is not that we need to dig open some new mines, but the more efficient recycling we have in the processes, the better we are off, I guess, and we can also, let's say, comply with the sustainability targets set in Europe. I think it's important to mention it here. We didn't cover that in the discussions at all.
I agree recycling needs to be part of the future, but most of the cars we need have yet to be manufactured at all. Most of the manufacturing is actually in front of us, and that'll have to come from raw materials, primary mining sources.
Oh yeah.
But we've got to build the circular economy, and the circular economy is recycling. And so to be sustainable, we've got to get to the point where we can recycle most of what we need, but we're not there yet.
Yeah, it will take multiple years to get there.
Yeah,
that's correct. Yeah.
And I think it's also one of the issues when we look at the new materials. So they tend to be always more complex than the old one which we have in use. So you have there various different materials which you need to then recover from the recycled product. So it's something to bear in mind also when we develop new alternative materials.
Mm.
Yeah. I would like to comment regarding risks that I think what has been clarified in the discussions of the speakers who just spoke is that there are two types of risk. One is the risk of new technologies, and as Ilka mentioned, there is currently quite an aversion for the risk of new technologies, so that with the gigafactory scale up, the tendency is to scale up the thing that works the best. And then there is the other risk of supply chain disruption, and that could happen if suddenly there is a geopolitical event or if we start to hit a capacity bottleneck. And the two are actually related, because if many gigafactories all bet on the same technology, then everybody needs as much graphite as possible or as much lithium as possible, and then there is a bigger risk of supply chain disruption. And on the other hand, if there is multiple various technologies that are being developed, then the risk of supply chain disruption decreases, but the risk of new technology is increasing. So I think there is a kind of a healthy balance between these two risks, and one has to find the healthy balance.
Mm. Yeah, thank you. At this point, I would like to remind the audience, if you have any questions, please just write them in the chat. Or do we actually have there already any questions? I have not checked.
At the moment, we still don't have any questions, so feel free if you have anything to ask, just write it down.
Yeah, please just do.
I have a question for Andreas.
Yeah.
So how one of the big challenges in front of us, for example, if we were to use, say, solar and wind as a power source, we need a battery energy storage buffer that can store at least 48 hours worth of power to manage fluctuations in power and then share it out. It's something like 48 hours as a minimum, but we're talking about these large storage banks of batteries. Now, in Australia, they've got this big lithium-ion farm that's 100 megawatt capacity. What chemistry do you think would be more useful for these really large storage stations? That you need something like 100 megawatts capacity in one site, but you have no weight restrictions or size restrictions. So, what battery chemistry do you think would work best?
Yeah, so well, I should of course say that our battery chemistry will work best, but that will be eventually. For grid storage, one of the key factors is the high round-trip energy efficiency of storage. So we want to get back as much of the energy as we have put in. And lithium-ion battery is quite good with that. So it has over 90% round-trip efficiency. Mm-hmm. And that actually we can also accomplish with our solar batteries. So we have now batteries which have 90% round-trip efficiency, but the cycle life is still not enough for grid storage. So in our case, we have to increase the cycle life before it can be used for grid storage. Now, to answer your question, it really depends on the capacity that's needed, because what's happening today, and the Australian example you gave is a good example, is that the manufacturers who manufacture electric vehicle batteries, they have two grades. After manufacturing, they separate according to quality into better and poorer grade, and the better grade they use for electric vehicles. The poorer grades they would normally just throw away or recycle, but actually it's very often the criteria of grid storage. So they can sell at very low cost those batteries that were already produced but did not make the quality criteria for electric vehicles. But that works only up to the capacity of what's left over for electric vehicles. If the capacity goes beyond that, then that's of course not a viable strategy anymore. And in my view, what is most viable today is the lithium iron phosphate or lithium iron manganese phosphate. So lithium iron phosphate has very long-term cycle life, And in case of lithium manganese iron phosphate cathodes, they have been investigated for 10 years, but their cycle life was the bottleneck for grid storage. And now with our electrolyte, we achieved lithium manganese iron phosphate batteries to have the same cycle life like lithium iron phosphate batteries. And this can be produced in quite large volume because you don't have nickel or cobalt bottlenecks. And compared to lithium iron phosphate, they have somewhat higher energy efficiency and also somewhat higher energy density. So that's what would be, I think, the best near-term solution for grid storage.
Okay. So the reason I say that is in the complete systems, the complete system replacement, where we actually phase out fossil fuels and we have renewable energies to take part. And we're actually looking at the grid storage battery capacity is about 3/4 of the required volumes of new batteries coming in. That's a very conservative estimate as well. So that to make solar and wind viable, we need to answer that question.
Yeah, exactly. So eventually it will be bigger than electric vehicle market. So there has to be some other solution eventually than the leftover batteries from electric vehicle making.
Absolutely.
And we have one question on the chat. It goes, if you had to pick one critical raw material whose need is going to explode in the future and that is going to face little competition, would you still say lithium, although it has a limited availability? And how much lithium there is left? And I guess there is no silver bullet there, or is it?
I would say nickel instead of lithium, because all research is pushing towards to remove cobalt, and one day someone's going to actually do it. And they're trying to reduce the lithium in there as well. So I think nickel is the. This is Tanya will probably be a better person to answer this, but to me, it's going to be a story about nickel rather than lithium or cobalt. Or Tanya, or do you still think lithium is still the leader?
Well, if you leave the lithium for electric vehicles and then use other ions or other metals for those batteries which are for storage and grid storage, then we are better with the lithium.
Okay, so it's lithium. Okay.
And then there is the next question. How do you see the potential of all solid-state batteries for the future?
Well, there's a lot of issues there to be solved yet, and I wish we have them in use, especially for the electric vehicle applications, because this is one of the approaches to increase the energy density and increase the lifetime so that we make the batteries more sustainable. But there are still issues related to interface stabilities and so on to be solved. It's one of these technologies to which I think we should have enough investments to investigate them.
And then to add to the lithium question, which is the most needed critical raw material for renewable energy technologies? Do you know that?
See, that's also a loaded question, because we need silicon metal to make solar panels. Now, while we've got abundant silicon on the planet, silicon metal is a different story. We need neodymium to make magnets to put into wind turbines. We have a relatively limited supply of that when we start talking about massive volumes. If we're going to go, so the hydrogen fuel cell, they need platinum and possibly silver. Both of those metals have supply constraints. I think with a lot of these sort of questions here is we are still in conceptual space, and it's not until we actually get out there and start scaling up that we see the true problems. That's an interesting question. I'm not entirely sure. I have the numbers at hand to say one metal over another. It takes time to go out and explore more, by the way. So I work with global resources, as quoted by the USGS, and it takes about 20 years to discover a deposit and take it all the way out to a functioning mine where nothing goes wrong. Right, and so our greatest commodity that we are missing, I think, is time. If we had another 50, 60 years, a lot of these problems could be resolved. We don't.
Yeah. But this, I think, is one of the reasons why, for example, I think that we should have different battery technologies in use and not only rely on one of them. This is the best way to create critical dependency.
Absolutely. Absolutely.
And actually, our last question is about that as well, because there is asked if it's all about materials or which role play the manufacturing technologies, especially which role can printed electronics play.
I think maybe Maria and Anders are the best people to answer this. But if we, for example, think of the next generation all solid state batteries, there the manufacturing technologies play an important role. So if we want to have, for example, ceramic electrolytes to be used, we need to develop technologies which allow us to make thin ceramic electrolytes, which are made in a protective atmosphere, so that we don't, because they are they can react with the air in a harmful manner. So there are also a lot of things to investigate in the manufacturing technologies to develop those in that level what we need when we go to more complex materials.
Yeah, and that's the reason, for example, why we at VTT are at the moment focusing on polymer electrolytes for solid-state batteries, since those we can coat under normal atmosphere. And this is kind of one of our focus areas to develop the manufacturing from the lab scale to the pilot level as well. So very, very important aspect to think of.
For me, society has two fundamental blind spots, and one is energy, like what energy do we use at the moment, and where do we get it from? And the other is materials. Where does all our we consume a vast amount of raw materials every year, and 80% of that through the market is coming from the ground, and we don't seem to understand that these are non-renewable resources. And we've had a wonderful run for the last century of abundant resources and abundant cheap energy. But now the challenge in front of us is different, and I'm not sure we understand that in large enough numbers yet. So.
I think that's a great comment to finish our conversation, as there is 2 minutes left of our time. So I want to say thank you for all of our panelists and all the people who attended the webinar as well. And as said in the beginning, we will add this webinar to our YouTube channel, so you can find it there. In case you missed some parts of the conversation, you can go there and check them again. So thank you very much, and I wish you all happy holiday time. It's coming soon, even though it's only the 1st of December. So thank you very much.
Okay, kiitos.
Yes. Thank you also on my behalf.